Grade ins, in our last lesson in chemistry, we're going to talk about a category of elements and compounds called acids and bases. So acids are a group of chemical compounds that we're quite familiar with. Acids are things that are sour tasting. We think of lemons and we think of vinegar. Acids are chemicals that turn litmus paper red, taste sour, and when they react with metals, hydrogen gas is produced. They're also good conductors of electricity and have very low pHs. The opposite of acids are bases. Bases are things like soap or bleach. When we put litmus paper into a base, it turns blue. Bases taste bitter and have a very slippery feel on our hands. They are also good conductors, so they have that in common. But these have high pH numbers. They're going to have pHs bigger than 7. Some common examples of acids are hydrochloric acid, which is the kind of acid you find in your stomach. Sulfuric acid is found in battery acid. Carbonic acid is found in carbonated drinks. And acetic acid is the acid that's found in vinegar. One thing you may notice about all acids is that they all start with hydrogen. Hydrogen is found at the beginning of every chemical formula, including an acid. Common examples of bases are things like sodium hydroxide, which is found in Drano. Potassium hydroxide, which, when mixed with sodium hydroxide, is the component in lye, which is used for making soap. Magnesium hydroxide is found in Tums. Sodium carbonate is a kind of a base found in baking soda. Most bases that you'll find in common will have OH groups as part of them. There are several bases that do not have OHs in them. Baking soda is one example. So is bleach. So one way that we recognize acids is that they'll always have hydrogen. And for bases, they will usually have hydroxide. In our last lesson on types of reactions, we remembered that an acid plus a base makes a salt and water. This kind of reaction is called a neutralization reaction. The part of the acid that makes it an acid, we found out, was hydrogen. And you'll notice that in hydrochloric acid, there's my hydrogen. The part of your base that makes it basic was the OH. When the hydrogen from the acid and the OH from the base get together, we have water. Water is a mixture of hydrogen and hydroxide. It's often written as HOH. Sometimes H2O, because it still has 2 hydrogens and an oxygen. Either way, here's the hydrogen that came from the acid, and here's the hydroxide that came from the base. Water is a neutral substance, which is why these are called neutralization reactions. The remaining elements, the sodium and the chlorine, got together to form sodium chloride. So that's what we call a salt. In this case, it formed table salt. When I was describing the characteristics of acids and bases, I mentioned pH and I mentioned litmus. pH is a scale based on the word's potential of hydrogen, and it's a simple way to tell if substances are acids or bases. Acids have pHs from 0 up to 7. So anytime you measure a pH and you get a range from 0 to 7, it's acidic. Very acidic things include battery acid, but lemons are also acidic, and even milk. Bases are things that have pH from 7 up to 14. The strongest bases are very strong and powerful and can cause a lot of damage. Weaker bases, like baking soda, are closer to pH 7. Remember, at pH 7, we are neutral. Water is considered a neutral substance, and you may have used pH paper before if you have a pool or a hot tub and you're testing the chemistry to determine whether the substance was an acid or a base. Another common tests for acid or base are indicator solutions. Litmus paper is a good example of an indicator solution. Litmus paper comes in two shades, a purpley kind of color that we call blue, and a pinkish color that we call red. It's really the same chemical. When you dip the litmus paper into an acid, it will turn red. Anytime that litmus paper turns red, the solution is acidic. And in the picture, you can see that we have the red color. If you dip the litmus paper into a solution and it turns blue, then it's basic. We always have to have both tests, because if I dip red litmus paper into an acid, it will just look red. It won't look like it changed color. That might mean it's an acid, but it might also mean that it's neutral. If I dipped blue litmus paper into a base, it would just stay blue. Litmus paper is always red in an acid and blue in a base. So we quite often test with both, because a red color might mean acidic, but it might mean neutral, as a blue color might mean a base and might be neutral. We're looking for a change in the color of the litmus paper. Two other tests that we can use are bromothymol blue and phenolphthalein. These are indicator solutions. Bromothymol blue, if I put a few drops into a solution, will turn yellow if the solution is acidic, and stay blue if the solution is basic or neutral. Phenolphthalein is a clear liquid. If I put it into an acid, it stays clear, but it also stays clear in a neutral solution. It will turn a bright hot pink color in a base. Because neutral solutions quite often don't result in color changes, it is important that we test both for acid and for base to make sure that we haven't tested and resulted in a neutral solution. Not everything is an acid or a base. To check your understanding of acids or bases, answer the following questions. I will produce a couple of more videos and link them below this one for you to view some of the acid-base reactions with bromothymol blue and phenolphthalein and with litmus paper.